Let's now prove that conjugation and multiplication commute over the complex numbers. So we have two complex numbers, so let W be equal to A plus BI, where our assumption is that A and B are both real numbers. And let's also let Z be equal to C plus DI, where C and D are also both real numbers. So let's start with the left-hand side and see what happens. W times Z conjugate. Well, W times Z, that's A plus BI, times C plus DI, whole thing conjugate. Okay, let's multiply out what's under the conjugation sign. We have A times C plus A times DI plus B times CI plus B times DI squared. And I need the conjugate of this whole thing. Now let's collect the real and the imaginary terms. The first and last terms are real because I squared is -1. So A times C minus B times D, collecting the first term and the last term. The middle two terms have an I in them, so I can write this as AD minus B times C times I. I'm sorry, this should have been a plus. So let me say that again. ADI plus BCI. And I need the conjugate of the whole thing. Now A, B, C, and D are real, so the thing in the parentheses here is real. Also, this thing in the parentheses is real. And so therefore I can take the conjugate as expected, A times C minus B times D minus A times D plus B times C times I. Okay, now I will separate this and kind of just basically undo the steps that I had before, except with a few minus signs added that I wouldn't have expected otherwise. So let me write this kind of like the line that I'm going to mark here in blue. I'm going to try to make it look something like that line so that I can factor it on the line after that. So A times C minus A times D times I minus B times C times I. And on this minus, let me turn to a plus I squared. B times D times I squared. Now these first two terms, I can factor an A out. C minus DI. On the last two terms, I can factor out a minus B times I, leaving me plus C and then a minus D times I. Then I can factor C minus DI out, so A minus BI times C minus DI, and that is equal to W conjugate times Z conjugate. And that is the end of the proof. Another way of doing the proof is to come to end the proof on this line. So just the first part we end on this line, and then to finish the proof what we would do is then that multiplies out the left-hand side. The right-hand side you also multiply out and then verify that you end up with the same thing. This way is a little bit cleaner because you start with the left-hand side and end with the right-hand side, but it would be perfectly valid to multiply out the left side, multiply out the right side, where W conjugate times Z conjugate, and then that's the end of the proof.